This is AP Calculus AB, Worksheet 2-3, General and Power Chain Rule. Our directions state, for each function below, first identify the outer and inner, then calculate the doubter and the dinner, the derivative of the outer and the derivative of the inner, and use them to find the function's derivative. Final answers must be completely simplified and have positive exponents only. And that'll be a big, important one for us. Don't have negative exponents. You have to flip it, right? All right, let's start off with a nice and easy one. Number one, the outer is going to be 2 times some stuff to the power of 2, and the derivative of that, well, this is powerhouse. Powerhouse, because the exponent is a number, 2 is going to be multiplied down in front. 2 times 2 is 4 times all of that inner stuff to the power of, okay, it used to be a 2, it's going to go down to a 1, but we don't write the 1. All right, what about the inner? The inside is x plus 1. And the derivative of that inside is just 1, because the derivative of 1x is just 1. The derivative of 1 is 0. All right, so now that we have our pieces, we're going to put them together where we do our calculation. Anytime you take the derivative, it's always the doubter times the dinner, the derivative of the outer times the derivative of the inner. So the doubter we have over here, it's 4 times some stuff. 4 times some stuff. What is that stuff? Well, it's the inner, it's the inside, it's the x plus 1. What is the dinner? In this case, it's just 1. When I multiply everything together, it's like you don't even multiply by the 1. It's not even there. I can distribute the 4 and call it a day. It's 4x plus 4. Let's do number 2. A little bit harder because we actually have a dinner that's not 1. For the outer, it's going to be 3 times some stuff to the power of 3. When I take the derivative of that, I identify this is indeed powerhouse because the exponent is just a number. It's not a variable. 3 is going to be multiplied down in front by the coefficient of 3, and then I'm going to get 3 times 3 is 9 times all of this power. This 3 is going to go down to a power of 2, and I'm done with the doubter. What is the inner? The inner is 1 over x. I want to take the derivative of the inner to get the dinner, but unfortunately, this is a fraction. I don't want to use quotient rule from 2-10. We haven't even learned about that yet, so I need to rewrite this as a non-fraction. I can say this is really x to the power of -1. And now this is just a powerhouse. I can multiply the -1 down in front. I can say this is negative x to the power of, it used to be -1, I'm going to go down a power to -2. And this is mathematically correct, but the instructions state that I cannot have a negative power in the exponent, so I'm going to rewrite this yet again. I'm going to say this is -1 over x to the power of +2. As a note, you can have that negative out in front like I do. You can have it either in the top or the bottom. One of those 3 places is fine. I just randomly chose to put it out in the front. So we're going to put those pieces together. I'm going to multiply the doubter times the dinner over here in the calculation section. So here we go. The doubter is 9 times some stuff to the power of 2. That stuff is the inner, 1 over x. I'm going to multiply by the dinner. The dinner is -1 over x squared. All right, I have all the pieces together. Let's go ahead and multiply. I have 9 times 1 over x squared. I'm going to go ahead and distribute the square to the top and to the bottom. So I'm going to say this is 1 squared over x squared. And I'm going to multiply that by a -1 over x squared. All right, the first thing I'm going to do, I'm going to pull out that negative out here. I'm going to say this is -9. I see a bunch of fractions, so I'm going to make this -9 over 1. So everything is a fraction. -9 over 1 times 1 over x squared times 1 over x squared. Again, I pulled out that negative here if you're curious where the negative went. All right, multiply all the numerators. That's going to be equal to a -9. Multiply all the denominators. This is, ones go away. X squared is x to the power of 4. Remembering your properties of exponents, you just add these exponents whenever I multiply same bases, and I get my final answer, -9 over x to the power of 4. Excellent. On to number 3. All right, number 3, the outer is going to be 4 times some stuff to the power of 7. The derivative of that, it's powerhouse yet again. The 7 is going to multiply down in front. 4 times 7 is 28. This is going to be multiplied by stuff to the power of, it used to be 7, it's going to go down to a power of 6. And then from there, I'm going to do the inner. The inner is 5 minus x. A lot of students will make the common mistake of saying, yes, Mr. Sindel, I know that the derivative of 5 is 0 and the derivative of x is 1, so the answer here is 1. That is incorrect. The correct answer is -1. Can you see why? It's negative 1 because, again, the derivative of 5 is 0, but the derivative of negative x is the same thing as negative 1x, and the negative 1 comes straight down here. Be careful. That's a very common mistake that students will make. Let's put the pieces together. So the doubter is 28 times some stuff to the power of 6. That stuff is 5 minus x. The dinner is just negative 1 in this case. Multiplying everything together is going to give us a negative 28 times 5 minus x to the power of 6. Final answer, and box it. I know students that have really mastered Algebra 2 and pre-calculus have asked the question, well, I know how to expand with powers of 6. You use Pascal's triangle to expand this thing, which takes a lot of work. Will I ever need to do that in AP Calculus A, B, or BC? And the answer is no for neither of them. No for both of them. In this class, you do not need to expand it. This answer is acceptable. All right. Moving on to the backside. Number 4. I have another type of problem that looks very similar to 3. The outer is going to be stuff to the power of 4. The derivative of that is going to be, well, it's a powerhouse, so the 4 is going to come down in front, and this is going to be 4 times that same stuff, now to the power of 4 goes down to 3. Okay, the inner is 1 minus 3x. We've been trained from last time to remember, there is a negative, and the dinner in this case is negative 3. All right, let's put those pieces together. The doubter is going to be 4 times some stuff to the power of 3. That stuff is the inner, which is 1 minus 3x. And the dinner in this case is negative 3. Multiplying together will give us a negative 12 times that 1 minus 3x to the power of 3. All right, moving on to number 5. The outer is going to be negative stuff to the power of negative 3. The derivative of that is going to be negative 3 comes down in front. A negative times a negative is a positive. I have a positive 3 times some stuff to the power of, well, it used to be negative 3. I'm going to go down to negative 4. All right, what is the inner? The inner is x squared plus 1. The derivative of each of those, the derivative of x squared is 2x. The derivative of 1 is 0, so I'm done. All right, now putting the pieces together. The doubter is 3 times stuff to the power of negative 4. 3 times stuff to the power of negative 4. That stuff is x squared plus 1. And the dinner in this case is 2x. And I'm realizing that this is correct. I probably should have rewritten it here, but it's okay. I can do it over here. I can't have a negative in my final answer, so I'm going to pull this entire thing into the denominator. 3 is going to be left in the numerator. So I'm going to have 3 in the numerator. The denominator will have this x squared plus 1, all of this to the power of now positive 4 because it got flipped, and this is being multiplied by 2x, technically 2x over 1. So when I multiply those together, I should get a 6x in the numerator, and the denominator should be x squared plus 1, that entire quantity to the power of 4. And we'll box it. I box work whenever I don't immediately jump to the final answer. All right, I think, yeah, this is indeed our last problem. It's a 1/2 power. So I could have instead given you guys a square root function, but instead I gave you a power of 1/2. I did one step for you guys. You're welcome. I could have made it harder. The outer is negative 2 times some stuff to the power of 1/2. The derivative of that, well, 1/2 comes down in front. A half of 2 is 1. Keep the negative, and I have a negative stuff to the power of, be careful here. I'm going to go down from 1/2 to negative 1/2. If you forgot why, let me quickly explain and I'll erase it. I'll leave it up maybe. So if I have 1/2 and I subtract 1, that's the same thing as doing 1/2 minus 2 over 2, which is the same thing as keeping the denominator. I have like denominators. 1 minus 2 is a negative 1. So I'll have a negative 1 here. There's the negative 1/2. All right, what about the inner? The inner is 3. Oh, I want to change back to red though. The inner is 3x squared. If I take the derivative of that, it's still powerhouse. 2 comes down in front. 2 times 3 is 6. 6x to the power of, it used to be a 2, goes down to a 1. I don't write the 1, and I've got my dinner. All right, multiplying the doubter times the dinner. This is the chance where we can say, okay, do we want to leave that negative right now or get rid of it later? I'm going to go ahead and get rid of it later. I'm just going to go ahead and rewrite this for now. It doesn't matter when you do it. So the doubter is negative stuff to the power of negative 1/2. And that stuff is the inner, it's the 3x squared, and the dinner is 6x. So multiplying these together, I'm going to have things that are left in the top. I'll leave the negative in the top. It doesn't matter where you leave the negative. It could be the top or the bottom, just out in front, wherever you want. I'm going to say negative 6x is going to be on the top. Just to make sure that you're seeing where I'm coming from, I'm going to leave the negative 1 in the top, and I'm going to put this 3x squared to the power of positive 1/2 in the denominator, and this is being multiplied by 6x all over 1. I'm writing it this way for the static answer key for those of the students that don't like watching the video. Now you can clearly see that, 6x times negative 1 is a negative 6x in the numerator. The denominator is, you can leave it like this. That's perfectly acceptable. I'm going to go ahead and do an alternate form just to practice. This could have been the square root of 3x squared. And that square root is a little bit too large for my taste. I'm going to go ahead and make it nice and neat and tidy better. All right. And because I did work, I should be boxing my final answer. There it is. Excellent. Well, that concludes AP Calculus AB's Worksheet 2-3 for General and Power Chain Rule. There's the back side. There's the front side. Thanks for watching.